Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through various forms of content, including articles, infographics, videos, and email newsletters. This video is part one of a three-part series where I cover advanced applications of integration by parts. For more information about this topic, please refer to the article linked in the description. In this video, we will use integration by parts to evaluate the integral of arcsine of x dx and the integral of arctangent of x dx. First, we evaluate the integral of arcsine of x dx. To begin, we choose u equals arcsine of x and dv equals dx. Then du equals 1 over the square root of 1 minus x squared dx and v equals x. Applying the integration by parts formula then gives us x arcsine of x minus the integral of x over the square root of 1 minus x squared dx. To evaluate the remaining integral, we let u equals 1 minus x squared. The differential is then du equals negative 2x dx. Dividing both sides of the differential by negative 2 gives minus 1/2 du equals x dx. Substituting into the integral then gives x arcsine of x minus the integral of minus 1/2 times 1 over root u du. Applying the constant multiple rule then gives x arcsine of x plus 1/2 times the integral of 1 over root u du, rewriting the root as a fractional exponent, then gives x arcsine of x plus 1/2 times the integral of 1 over u to the 1/2 du. Integrating, we obtain x arcsine of x plus u to the 1/2 plus c, rewriting the fractional exponent as a root gives x arcsine of x plus root u plus c. Back substituting, we arrive at a final answer of x arcsine of x plus root 1 minus x squared plus c. Lastly, we evaluate the integral of arctangent of x dx. To begin, we choose u equals arctangent of x and dv equals dx, then du equals 1 over x squared plus 1 dx and v equals x. Applying the integration by parts formula then gives x arctangent of x minus the integral of x over x squared plus 1 dx. To evaluate the remaining integral, we let u equals x squared plus 1. The differential is then du equals 2x dx. Dividing both sides of the differential by 2 gives 1/2 du equals x dx. Substituting into the integral gives x arctangent of x minus the integral of 1/2 times 1 over u du. Applying the constant multiple rule gives x arctangent of x minus 1/2 times the integral of 1 over u du. Integrating gives x arctangent of x minus 1/2 times ln absolute value of u plus c. Back substituting, we arrive at a final answer of x arctangent of x minus 1/2 ln absolute value of x squared plus 1 plus c. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.